Hello, my name is Mangole Dorothy, and thank you for this opportunity to discuss these SQL fundamentals. And I'll be answering these questions. And the first one is, how do you how do you explain what SQL is to someone without a technical background? Just imagine your company keeps all its important information like customer details, orders and products in giant, well-organized filing cabinet made up of many drawers. Each drawer has labeled folders with specific information inside. So SQL is simply the language you use to politely ask the filing cabinet questions such as show me all the customers who placed an order last month, or how many products do we have in stock under maybe $50. So you don't need to know how the cabinet is built internally, but you just ask clear questions, and SQL helps the database find, combine, and update exactly the information you need. And the second question is, what are the different types of keys in SQL, uh, and when do you use them? So keys are special columns that help identify records and maintain relationship in database. A primary key uniquely identifies each row in the table and cannot be known. We use it as the main ID for a record. For example, an employee ID or order ID. It ensures no duplicates and speeds up lookups. And then the foreign key is a column in one table that references the primary key in another table. We use it to create relationships between tables, for instance, linking an order or a table to a customer. So every order knows which customer it belongs to. Then a candidate key is any minimal set of columns that could uniquely identify a role. The primary key is usually chosen from the candidate keys. Then the alternate or the unique key is a candidate key that wasn't selected as the primary key, but it enforces uniqueness, such as an email address. And then a composite key uses multiple columns together to uniquely identify a role. It's useful when no single column is unique on its own. And then a storage key is an artificially generated key, and it's used when a natural business key is impractical. So I'll go to the other question. Can you list all of the joins in SQL and the use case for each of them? So for this one, I can say I know the inner join, the left outer join, and the right outer join, the full outer join, and cross join. And for the first one, the inner join returns only the rows where there is a match in both tables. Then the left join returns all rows from the left table and only the rows from the right table. And then the right join, the right outer join, the opposite. All rows from the right table and matching rows from the left. Use the use case showing all departments and the employees in them. Then the full join returns all rows from both tables with no match. Then the cross join returns um, the product, every row from the first table paired with every row from the second. Then the self join, it joins a table to itself. Um, so choosing the right join depends on whether you want only matches or all records from one side or everything. So the last question is, what is the importance of data integrity in your work with SQL? So data integrity means keeping the data accurate and consistent or complete or maybe even reliable throughout its a life cycle. In SQL work, it is critical because decision reports and machine learning modules all depend on trustworthy data. Without integrity, we risk duplicate records, broken relationships, invalid values, or accidental deletions. This can lead to wrong business insights, uh, uh, or lost customer trust. And we can maintain the integrity through constraints, proper normalization, validations at the application layer, um, and regular audits or monitoring. So investing time upfront in strong integrity rules saves firm time later fixing bad data. Thank you for listening and watching. I'm happy to elaborate on any of these topics and walk through a live example if needed.